Hello and welcome to Platform Engineering for Software Developers and Architects. My name is Daniel Bryant. I'll give you the full introduction to myself in just a moment, but I like to start my talks with high-level key takeaways, the TLDR, if you like. Now, the three things for this talk I want you to take away are on the screen now. First off, platform engineering should have a product focus. Our developers are our customers. We're not just trying to shoehorn DevOps into the organization under a different name. We're not trying to rebrand it. We as developers and architects should also make sure we're getting a platform from this new emergence of platform engineering. We're getting a platform which should be a product to help us deliver value faster, safer, and at scale. Now, platform architecture and software architecture are symbiotic. We can't, as software architects, just throw our stuff over the wall and hope it works. But also, we've got to expect from the platform team some form of our platform that helps us deliver value, makes it easy to do the right thing. Often say shift left, right? But we don't want to overburden ourselves. So the key thing here is platform architecture and software architecture are very much one and the same thing. We need from both sides of the house to make sure we're working well effectively together, because after all, software delivery is a team sport. And finally, good APIs, abstractions, and automation are the prize for everything. I think this is valid for developers, architects, and platform engineers, platform architects too. But definitely from the platform engineering side, we shouldn't just expect tools are going to be swapped out. An old OPSI tool or a DevOps tool shouldn't just be swapped out for a platform engineering tool, a cloud tool, or whatever. We really need to think about the APIs, the abstraction, and the automation at all levels of our stack. Definitely APIs and abstraction are really important in software delivery and software design, but also in the platform itself too. Very quickly, this is me at Daniel Bryant UK on most of the interwebs. I've had a 20 or so year career as a Java developer, then moved into more like JavaScript, Go, Ruby. Along the way, did a whole bunch of OPSI stuff and a whole bunch of architecture stuff too, and ultimately moved into doing platform rescues with a consultancy based in London called Open Credo, and learned a lot about Cloud Foundry, Heroku, Mesos, of course, Kubernetes at the end of my time there as well. And after that, I've worked on many open source tools, and my love of platforms now is solidified working with the Syntasso team, working on Kratix. So if you're building a platform, check out Kratix. It's a great platform orchestration framework, which I'll go into in more detail now. But yeah, I love to share my knowledge along the way, written a few books and things as well. So reach out if you need any help. I'm happy to do my best. So I did this talk, or a talk, 3 years ago now at KubeCon in Valencia, and also PlatformCon virtually about 3 years ago, 2022. And what I said is I really like this definition of platform by Evan Botcher. There's no point in me trying to invent my own definition. This is a great definition. It focuses on the socio and the technical. We've got self-service APIs, but we've also got knowledge and support. And Evan said you're trying to deliver a compelling internal product. This is that platform as a product notion to help the software delivery teams, the streamline teams, the sprint teams, the scrum teams. You're trying to help them deliver value faster with reduced coordination. And also implicitly there is like being safe and operating at scale too. But I really like this definition of we are building a platform as a product. I as a developer, I as an architect should be a customer of that platform, right? I talked back in this talk 3 years ago about this CNCF, the Cloud Native Computing Foundation, being a foundation for what I and a few others at the time were calling a developer control plane. Now, I think the terminology shifted. You can still see the developer control plane, DCP, in some of the diagrams and some of the sort of reference architecture online. But the really important thing here is the sort of the tiers of the architecture, if you like. If you look down the bottom, I know as a developer I needed to code, I needed to ship, I needed to run. And there was kind of various tools I was working with at the time. I was working with telepresence, I was working with emissary ingress, working with Argo. And I knew, like, as a developer, I needed these things, these tools, and then like kind of the abstractions above, like dev environments, continuous delivery, API management. But then how did I interact with all these disparate tools? Yes, Backstage was just emerging back 3 years ago. Clutch was coming out of Lyft, and it's not gone so far as say Backstage now. Backstage is kind of kicking ass when it comes to portals. But there is Port, there's Cortex, there's other ones as well. Many companies have got their own internal portal they've worked on, and this is a great kind of interface into the platform. But there's a layer between all this sort of API and UI and CLI goodness and the actual infrastructure and the tooling. And I didn't know what to call it back then. I just said leverage webhooks, CRDs, APIs to build integrated workflow. Now I'd call this the platform orchestration layer, but I didn't know what that was back in the day. But this was kind of like the emergence of my thinking, standing on the shoulders of giants for sure. I'm not claiming I come up with all this stuff, but this is one of how I saw early platform architecture 3 years ago. This, like I say, backstage really was an emerging thing. Now it's just gone, sort of rocketed, right? But do be aware that a portal is not a platform. I see confusion with IDPs, internal developer portals, internal developer platforms. For me, a portal is just one part, an important part, but one part of your platform. I also said three years ago, always think about the goals of your platform. Why are you building the thing? And for me, it's going faster, decreasing risk, and increasing efficiency. And I've not made this up, right? This is from the awesome Team Topologies book. Check it out if you haven't already. Fantastic book. As a developer, as an architect, this book gives you a good insight into organizational design, organizational dynamics, all these good things. And then if you marry it up with Gregor Hopper's book around platform strategy, it's a real nice way to frame like why are we building this platform? Why have we assembled a platform team? What's the actual purpose of building the platform? It is these three things in my mind. When you're talking to various folks in the organization, another of Gregor's books is really useful. He talks about kind of how to articulate various goals and delivery value propositions, depending on whether you're talking to the C level, whether you're talking to middle management, whether you're talking to the individual contributors, and sort of what roles they're playing, how to articulate your goals, and how to articulate what you need for the platform in this example. So these three books with these three kind of goals are really key to bear in mind when you're building a platform. Why are we building it? How do we assemble the organization to get everyone aligned and delivering the platform? Let's now look at platform architecture. This is what you're probably most interested in, right, as developers and architects. Now, this is a bit of an eye chart slide. You can read the blog at your own time. You can look at the actual stuff I'm going to put up on your own time. So I'll rattle through it. But I like three tiers. Comes from my old school Java days, right, where we had various tier systems we built. But I think it often helps me conceptually to keep, see what is in each layer and what APIs separate those layers. The first layer, I've called it application choreography, a bit of a controversial name. I think we need a better name for it. But this is where the rubber meets the road. This is where developers, we interact with the platform. We're coding, we're shipping, we're running. We're typically maybe using portals to provision infrastructure, CLI tooling. We're doing declarative config sometimes. This is where we are focused on the software delivery cycle, life cycle. We're looking at coding, shipping, running, testing, and QA is obviously key to that too. Further down in the stack, there's infrastructure orchestration composition. Again, not too controversial, I don't think. It's where you're planning, building, maintaining the sort of rise of infrastructure as code. This is where folks like operators and sysadmins, infrastructure folks are using Terraform, Crossplane, Ansible, Bash, all these good things to build out the underlying infrastructure. The thing is, there's a bit of a gap between what we as developers, architects use and this infrastructure below. And it's like the abstractions often leak up from the infrastructure into our realm as developers and architects. So we have to know about Kubernetes. We have to learn Terraform, and that can be a bit too much sometimes. We're already juggling all this other stuff going on, and now we're having to learn about AI, right? How to use AI better. But I think for me, this middle layer is critical. I hinted at it earlier. Platform orchestration. It is where you're building out the sort of everything as a service from your platform. You want to automate your compliance, your regulatory requirements, all these kind of good things. And you want to be able to manage your platform as a fleet. Whether you're upgrading one database or 1,000, kind of should be the same process, right? And for me, this platform orchestration layer feels like the right layer to be putting in platform APIs, good platform abstractions relevant to your business, and you should be able to fleet manage these things at scale very easily as developers too. This is all focused on platform APIs, platform lifecycle. You can see some tools and example tech. Obviously, Kratix I'm working on. Humanitech have resource definitions, with very sort of comparable in some ways to things like Kratix promises. There's also cross-plane compositions, and I'd even argue the Argo and the Flux CRDs for progressive delivery are in this kind of space too. Sometimes there's different abstractions within all those tools, but the kind of goals are the same. You're talking of platform API layer. You're not up the top with the app dev teams. You're not quite down to the infrastructure stuff. This platform API is a really key layer to provide the right abstractions for us as devs and architects to get our work done. What I do like is when I look around and I see other people saying similar things. Again, not claiming credit for the last slide. I mean, I did put it together, but I was standing on the shoulders of giants. But over the last sort of year or so since I've been working on this, I've seen other folks like Gartner kind of came up with this. If you look at it, and the red annotation is mine, but you can kind of see the three tiers in what Gartner are talking about when they're talking about platform engineering. I had some fantastic chats with Keith Morris, who's got this amazing infrastructure as code book. I remember reading the first edition many years ago. It's one of my Bibles when it comes to infrastructure as code. And he was talking about these three layers in a platform too. And Keith and I had a great chat at KCD last year and some other places we bump into each other. I thought this is really cool. other people are thinking in these three-tier sort of mindsets. And Camille and Ian's book, fantastic book. This is an amazing platform engineering book. I was reading it on the flight over to KubeCon last year, and I sort of saw the three tiers in their book too. And they even sort of explicitly called it out in terms of when you're building a paved path platform, as they call it. So check out all these resources. I think this three-tier thing helps us with abstractions as developers, sort of thinking about what can we expect and how do we interact with the platform. But if you're new to this, check out the platform orchestration layer. Is probably where the most interesting things are going on at the moment. People are getting portals. Again, AI is infusing that layer as well. People are getting infrastructure as code. I don't think they're quite getting platform orchestration. And if you do want to have that good dev experience and you want to be able to do it over the long haul, so like we often talk about day two, if you don't get your APIs, abstractions, and automation right, that day two experience of upgrading, of observing can be really messy. This is where platform orchestration is really key. Now, I'll rattle through some architecture case studies, try and help you map a little bit some of the perhaps challenges between how platform architecture influences software architecture and vice versa, and give you a framing for jumping off in terms of exploring these things as well. So when I started my coding journey, it was all about hexagonal architectures. We created cohesive business code, clear APIs and abstractions that integrated into the platform, and this was all, easy to test your business code, easy to swap out platform components. But the reality was a bit different. Again, 20 years ago, lots of heavyweight middleware, enterprise service buses, all the kind of classic SOA stuff. We were often highly coupled into the platform, like the enterprise service bus, and I had to deploy code there as well as my app server. So I was coupled, like in terms of my deployments. There was often too much magic going on. People tried to hide the fact you were going over the wire versus doing things locally. The abstraction never quite worked there, and some of the transaction processing was like super complicated when it went wrong. So good ideas was a little bit challenging. Folks like Netflix really pioneered making components sort of custom to your business, or exposing some of these custom components into software so you can configure them in a much easier way. So service discovery was a classic thing, like some of the locking and queue management in distributed systems. The Netflix OSS folks really pioneered this stuff. The challenge was it was all written in Java, so if you were writing Java code, happy days. If you're writing Go and other things, the actual implementation Netflix had was highly coupled to the Java space. What kind of emerged around this were things like sidecars. So regardless of what language you're writing in, you could call out over HTTP to the platform resources. And the Netflix OS stack, and then Spring Cloud, and ultimately things like Dapper emerged that made this even easier for us developers and architects to work with. And if you look at the Dapper architecture diagram, you can literally see the three tiers I've talked about, right? Their SDK at the top, the kind of APIs in the middle, and then the actual infrastructure below, which I thought was kind of cool. You still need this notion of golden bricks, right? You've got to assemble your platform, your various bricks, to create your golden path. But the things like Dapper give you a really nice API into the platform, like now. Microservices popped up, right? We all love microservices, but more services, more problems, I think is the vibe, right? I remember classic, Martin Fowler article popped up saying if you're building microservices, got to have rapid provisioning, basic monitoring, rapid app deployment. The challenge where a lot of folks thought this rapid provisioning was all like, do I have ServiceNow tickets? It's self-service. Can I create a Jira ticket and suddenly a database appears? Like that is not self-service. That's not really rapid provisioning, right? And I saw a lot of folks cheating at the time. Their platform architecture was influencing heavily their software architecture. So they were building microservices, but deploying them all in one go. And this is the distributed monolith anti-pattern. I also saw a whole bunch of DevOps, you build it, you run it. Fine for small companies, for big banks, you can't do that. Like there's got to be some kind of centralized guardrails, some standard way of doing compliance, some standard way of doing logging, these things. So you couldn't really fleet manage effectively when you were embracing DevOps in kind of the way it actually turned out. I'm sure the original proponents of DevOps would argue to me there and say like, hey, DevOps, does scale. I'm sure it does, but the way I saw it being done in a lot of companies did not scale very effectively. Now, platforms kind of came up to address some of these concerns. We had Heroku, Cloud Foundry, all these good things, depending on whether you're a small company, a large company. And there was a lot of pushback around developers having to learn things like Terraform and Crossplane. Being given templates has always been an anti-pattern, because once you've been given a template, how do you look after it going forward? You are now responsible for that template. We often joke, puppy for Christmas. Fun on day one, day two can be more of a challenge, right? There is a bunch of tech emerging in this space to help with this. Things like OAM, score radius, there's daggers popped up now, like sort of nice abstraction layers around like building CI/CD. Of course, Kratix that I'm working on too. You can see the three-tier architecture in the way Kratix works as well. And the real key thing here is we're trying to provide APIs and abstraction layers, frameworks, if you like, for developers and platform architects, platform engineers to build appropriate code into each level and expose that up for us as developers and architects to actually use the platform effectively. Again, always think about this golden bricks. You've got to be able to assemble the components of your platform as you need. A really key thing here. And I think a lot of folks just want to go golden paths, and that can be a bit too constraining at times. Finally, I just want to mention cell-based architectures. Really interesting stuff coming up. So Microservices plus. A key thing with cell-based architectures is managing your fleet. So if you don't get that one right, it's really hard to roll out cell-based architecture. So check that one out too. Whistle stop tour, I appreciate it. There's a longer version of this talk from KubeCon you can check out if you want more details. What I would just say for conclusions, as developers, as architects, we are the customers of the platform. You have to demand platform as a product, aim for that speed, that safety, and that scale, and think API first. Don't just think a portal is going to solve your problems. You need to think about that platform orchestration layer too. The platform and the software architecture are symbiotic. Aim for that multiplayer mode. You want to be able to have everyone contribute to your platform and you want to all work together. Again, software delivery is very much a team sport. At the end of the day, the APIs, abstractions, and the automation are key. Think coupling and cohesion, think leaky abstractions. Should developers be learning Terraform? Probably not, right? But how does the platform support that kind of thing? And think about these golden bricks and golden paths. I think it's tempting to want to build a golden path to like do everything for you, but these often become, as the analogy says, golden cages. Really, we need to build components within our platform that are golden bricks. We can then assemble together and actually get our work done as developers. At that point, I'll say thanks very much. Check out the Kratix docs. Ping me on Twitter, X, GitHub, other places too if you do want to get in contact. Thanks for your time.